Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain and today we are going to study about some applications of trigonometry. Till now you have studied in trigonometry about 6 trigonometric ratios and their values at some special angles. After that you studied about complementary angles and then we saw some basic trigonometric identities, right? Now in this chapter we will use that knowledge to find to solve some real life problems, right? Such as finding the height of a tower, right? Let us say you are given this is the tower, right? And you know this distance, this horizontal distance and this angle, right? Now you need to find this height of tower. So we will use the concepts of trigonometry to find various heights and distances in this chapter, right? So let's first of all revise some of the concepts of trigonometry. Like I taught one mnemonic to you, so ka toa, right? In a right angle triangle, sine of an angle theta means opposite side by hypotenuse. For example, if this is the theta I am referring to, then sine of this theta will be equal to what? BC divided by AC, right? What is cos theta? Cos theta is adjacent side divided by hypotenuse, and tan theta is opposite by adjacent side, right? We learnt about these three trigonometric ratios and then we also saw that sin theta is nothing but reciprocal of cosecant theta, cos theta is the reciprocal of secant theta and tan theta is the reciprocal of cot theta, right? So these were the 6 trigonometric ratios that we talked about in previous chapter, okay? And let me tell you about 2 special triangles. One is 30, 60, 90 triangle and another one is 45, 45, 90 triangle, right? What I mean is, let me take this right angle triangle here. If this is a right angle and let's name these vertices as A, B and C. Let me take this as 30 degrees. So this angle will be 60 degrees, right? And 45, 45, 90 triangle I mean is, let me take this as 90 degrees. If one of these angles is 45 degrees, the other angle will also be 45 degrees, right? So now, what can you comment on the ratio of these sides of this triangle? For example, if I take this triangle here, 30, 60, 90 triangle, what I can say is that tan 60 in this triangle is equal to AB upon BC, right? And what is tan 60? Tan 60 is root 3. So AB is equal to root 3 times of BC, right? So what if I take this length as x, then I can say that AB is equal to root 3x, right? And what can you tell me about AC? AC, you can apply Pythagoras theorem or you apply some other trigonometric ratio like sin 60. What is sin 60? Sin 60 is opposite by hypotenuse. What is opposite side here? Root 3x and hypotenuse is AC. So what will be the length of AC here? It will be equal to root 3x divided by sin 60. And how much is sin 60? Sin 60 is root 3 by 2. So this 2 will come in the numerator and this root 3 will get cancelled. Hence, AC is equal to 2x. So, I can write this AC as 2x. Now, what can we say about the ratios of these sides? That the side opposite to 30 degree is x and side opposite to 90 degrees is double of x, that is 2x, and side opposite to 60 degree is root 3 times of x. So, the ratio of sides opposite 30 degree, 60 degree and 90 degree is x is to root 3x is to 2x. So, if I ignore this x here, I can say that the ratio is 1 is to root 3 is to 2, right. So, in a 30, 60, 90 triangle, the ratio of sides is always going to be 1 is to root 3 is to 2, and you need to take care that 1 is opposite to 30 degrees, root 3 is opposite 60 degrees and 2 is opposite 90 degrees, right. What I mean here is, if let us say you are given a 30, 60, 90 triangle, let us say this is your 30 degree angle, this is 60 and this is 90 degree angle. If you know that the side opposite to 30 degree is 2 units, okay, then what can you say about side opposite to 90 degree? That it is just the double of this side, right. So, this is 4 units, right, and side opposite to 60 degree is root 3 times this side. So, it is root 3 into 2, that is 2 root 3. Okay. So, you can directly comment about the other sides if you know that the triangle is 30, 60, 90 triangle and you know one of the sides, right. So, in a competitive examination, you can do it really fast if you know this fundamental. And similarly, in 45, 45, 90 triangle, what we can say is, see, 45, 45, 90 triangle is essentially an isosceles triangle. These two angles are equal, so the opposite sides to these angles are also equal. So, this side AB is equal to side BC, right. If I take this side BC as 1 unit, I can say that AB is also 1 unit, right, and by applying Pythagoras theorem, I can say that side AC is equal to 1 square plus 1 square square root, that is root 2 units, right. So, this side is going to be root 2 units. If I start with BC as 1 unit, okay. If I take BC as x units, then AB will also be x units and AC will become root 2x. So, the ratio of sides opposite to 45, 45 and 90 is equal to 1 is to 1 is to root 2. Okay. So, if you have got a 45, 45, 90 triangle and you know one side, you can easily comment about the other unknown sides, right. Okay. In this chapter, we will use another fundamental, which is, let us say this is a horizontal line, okay, and here we have got an observer, right, and you have got an object at certain height, okay, and observer is looking at this object from here. So, what we can say, let us learn some of the terms. This is the object and this is our observer, okay, who is looking at the object, and this is horizontal line. So, this line is known as line of sight, along which the observer is looking at the object, okay. This line is known as line of sight, and this angle here that is made with the horizontal line is known as angle of elevation. Okay, and you need to take care that you make every angle with the horizontal line, Okay, don't confuse it with any vertical line, right? So if even if the observer is sitting at the height, let us say observer is sitting here at certain height and object is here, right, and observer is looking at the object from this height h, right, then this line is now line of sight. Okay, and this angle you make a horizontal line here, and this angle here is known as angle of depression, right. Angle of depression is again made with a horizontal line. So this line is parallel to this line, right. So this is horizontal and this is vertical. Some of the students confuse it with this angle. No, this is not the angle of depression. Angle of depression is made with the horizontal line again, right. And if you notice, this line and this line is parallel, so this angle of depression is equal to this angle here. Okay, so you need to take care of these terminologies, and you should be thorough with the values of angles like tan 30. How much is tan 30? It is 1 by root 3. What is tan 60? Tan 60 is root 3. So you should be thorough with values of all the angles that we taught you in the chapter of trigonometry, and then you can start the